Okay, so for our warm-up, we're just focusing on combining our like terms to simplify our expression. We're also identifying what our terms are, what are our like terms, what are our coefficients, what are our constants. So remember, terms are separated by addition and subtraction signs. So if we take a look at this first one, I can build a wall right here to create my first term, which is 4D. I can build another separation, so there's my second term, 5D. I have another term, which is -6. I'm going to put little parentheses. I have a 3D. I have a -4D. And then my last term, which is a +5. So there's all of my terms. I've got 6 total terms to deal with. Now my like terms, remember like terms means that they have a common variable, right? The variable is the same, raised to the same power, or they don't have a variable at all. So I have 2 sets of like terms. My first set of like terms is going to be those terms that are variables of D. So I have a 4D. I have a +5D. I have a +3D, and I have a -4D. Okay, so these are all my sets of like terms for my variable. 4D, I have a +5D, I have a +3D, and I have a -4D. Okay, and then I've got my constants that are a like term set. So I have a -6 and a +5 that are going to be for my like terms for my constant. So -6 and +5. Okay, the coefficients are the values that belong with the variables. It's not the variable itself, it's just the number attached to the variable. So I have a lot of different coefficients. I have a +4, I have a +5, I have a +3, I have a -4. All of these are going to be a listing of my coefficients. And then my constants are what's listed down here. I have a -6 and a +5. Okay, now simplifying my expression means I'm going to focus on these like terms and combine those like terms as much as I can. So I can combine 4D plus 5D plus 3D minus 4D. When I combine those together, what do I get? 8D, right? If I combine these together, 4 plus the 5 is 9, 9 plus the 3 is going to give me 12, 12 minus this 4 is going to give me 8. So all of this together is going to come out to 8D. Okay, then I also have to focus on the constants, that -6 and that +5. What's -6 plus 5? -1. So we'd write -1. So there's my final answer then. In simplest form, my final answer is 8D minus 1. Cannot combine those together at all. Okay, taking a look at the second example, we have 5 minus 4x minus 8 plus 3 plus 16x. Again, we got to identify our like terms, our terms first, then our like terms, then our coefficients, and then our constants. So in this situation, my first term is at +5. Next term is a -4x. The next term is a -8. Then we've got a +3. And then we've got a +16x. Okay? For our like terms, if we focus on the variables first, we have our -4x and a +16x. -4x and +16x. That's a set of like terms. Then we've got our constants. We have a +5, a -8, and a +3. So +5, -8, +3. Okay, again, the coefficients are the numbers that are attached to those variable terms. So we have a -4 and we have a +16. And then for our constants, 5, -8, +3. Those are our constants. All right, if we go ahead and combine our like terms to simplify it, so we have -4x plus 16x. When we combine that together, that's going to give us a +12x. And then when we combine our numerical terms, so we have a positive 5, a negative 8, and a positive 3. When we combine those together, what do we get? 5 minus 8 plus 3. What does that become? 0, right? So it's like, oh, I'm adding a 0 or even subtracting a 0. But do I have to write the 0? No. So my final answer can just be 12x. You don't have to write plus 0 or minus 0 because the 0 is not going to affect it for addition. All right, our last example down here is finding the perimeter of a shape. Guys, what does it mean to do when we say find the perimeter? What operation are we utilizing when we're finding our perimeter? Io? Addition. Thank you. So we are adding all of the sides together. That's what it means to find the perimeter. You're going to add all of your sides together. Okay, so I'm adding all the like terms together first. So let's focus on what our like terms are first. We have a 7x. Does 7x have any like terms with it? What are the like terms? Good. We've got 15x, which was a positive, and we've got a negative 9x. So those are like terms that we can combine together. So I can say 7x plus 15x minus 9x. I can put all of them side by side because I'm adding all these terms together. Okay, then I've got my constants. I don't have any constant here. I do have this negative 5, right? If it says minus 5, that acts like a negative 5. I also have this negative 8 that can get combined together. So I can write that negative 5 plus negative 8, or you can just write minus 8. Negative 5 minus the 8. Okay, when we combine all of this together, 7x plus the 15x minus the 9x is going to come out to 13x. When you combine your constants together, you're going to get negative 13. So there's your final answer. 13x minus 13 is your perimeter. Any questions? Okay. So today's material is really, really easy. Factoring. So we've already covered distributive property. Distributive property indicates that we need to go ahead and multiply a value to each of the terms on the inside of a parenthesis set. What we're going to be doing today is basically undoing distributive property. We're going to identify things like greatest common factor. When I say greatest common factor, what does that mean? If I ask you for the greatest common factor between 8 and 12, if I'm asking for the greatest common factor of 8 and 12, what am I looking for? Fahim? The greatest multiple of both? So multiples would mean, okay, so I've got 8, 16, 24, and it keeps going on, right? That's multiples. Okay, so again, multiples means you're multiplying. You're finding all the things that you can multiply using that 8. Now, I'm not wanting multiples. I want greatest common factor. What would a factor be instead? Think multiples is multiplying. What would the factor be instead? Okay, and how do we find those factors? It's the largest number that can what? That can divide it. The largest number that can divide it. Okay, so let's go ahead and flip our paper on over to the back. Okay, so when we're talking about the largest common factor, the greatest common factor, GCF, that's what we're looking for. That is the largest number that can divide both. We're looking for the largest number that can divide into both of those numbers. Now, it's not always going to be just a number. Sometimes you might have a variable that's a common factor as well. Sometimes you might have a variable that's a common factor as well. Okay, so here, what I said before, I know that with distributive property, I know I can multiply 5 times 4x and 5 times 7, and that's going to give me 20x plus 35. When I say I want to factor it, I'm basically undoing that multiplication. I'm looking for whatever's the largest value that can go into both 20 and 35 and be divided out of it. So to factor it, you would start with 20x plus 35, and you would work your way to becoming 5 times 4x plus 7. So you're undoing that distributive property. Okay, so if we take a look here, 18x minus 24. The first thing that I want to do is figure out my factors. So we're going to start with the 18, and we're going to list off all the factors that create the value 18. So for my factors of 18, I know that I can do 1 times 18. I can also do 2 times 9. I can also do 3 times 6. And then that's all the factors of 18. Then I want to do the same thing for 24. Now I'm going to ignore my signs for the time being. I'm going to ignore the minus sign. I'm just going to focus on the base. So I'm focusing on factors that are going to create the value of 24. So my factors for 24 are also 1 times 24. So we have a 1 that's in common. We also have a 2 in common, 2 times 12. We have a 3 in common, 3 times 8. We also have a 6 in common, because 4 times 6. Okay, but again, I want the greatest common factor. So even though they do share a 1, they share a 2, they share a 3, the largest factor that they have in common is that 6. So the 6 happens to be my greatest common factor. So what I want to do is I want to take these values, this 18x minus the 24, and I'm going to divide each of them by 6. Because I'm going to pull that 6 to the outside of my parentheses. Now when I do 18 divided by 6, what is that going to leave me with? What's 18 divided by 6? 3. So then what is 18x divided by 6? 3x. So we're left with 3x. We still have our minus sign, right? The minus sign's not going to change. What's 24 divided by 6? 4. And there's your final answer. Very simple, easy material. You are just undoing what distributive property had done in the first place. So we're going to start with our first factor here, or our first term. We've got the 21. We want to go ahead and identify the factors for 21. So who can tell me what are the factors of 21? Just listing the factors of 21. Madison? Okay, we have 3 times 7. What else do we have? Io? 1 times 21. Okay, we have 3 times 7. We also have 1 times 21. Okay, now we're going to focus on the factors of our 14. Okay, who can tell me all of the factors for 14? Isaac? And then what else? 2 times 7. Good. Okay, so then what is our greatest common factor up here, guys? 7. Right, the greatest common factor happens to be the 7. So our GCF is going to equal 7, which means when I go ahead and factor this expression out, so I'm taking that 21x plus the 14, I'm going to divide each of these terms by 7 and pull that 7 onto the outside. And what's going to be remaining on the inside is going to be 3x and then plus 2. And there's our final answer. Okay. Now problem number 3 is even though it has more than just 2 terms, it's still going to be situated the exact same way. Okay, we're going to focus on our first term that we're going to be simplifying. Then we've got our second term's number value that we're going to be simplifying or factoring out. And then we'll deal with our third term. So we'll have a new color in it. Okay, so let's focus on the 12. Let's do our factors of 12. Who can list off all the factors of 12 for me? Brittany? Okay. 2 times 6. Okay, and 3 times 4. Good. So there's all of our factors for 12. We've got 1 times 12, 2 times 6, 3 times 4. Okay, now let's go ahead and focus on the factors of 4. What are the factors of 4 going to be? Mackenzie? Huh? Factors of 4. Just the factors of 4. 4 times 1 or 1 times 4. What else? Fahim? 2 times 2. Okay. All right, and then we've got the factors for 20. Okay, listing off all the factors of 20. What are those going to be? Madison? Okay, 2 times 10 we've got. What else do we have? Go ahead, Fahim. 4 times 5. And of course, we always have the 1 times 20, right? You always got 1 times the number. Okay, what's our greatest common factor here? 4, right? They all have the 4 in common. So our greatest common factor is going to be equal to 4. So when we divide this whole thing out, so 12x plus 4y plus 20, we're going to divide each of those terms by 4 and pull the 4 onto the outside. So 12x divided by 4 is going to give us 3x. 4y divided by 4 is just going to give us 1y, or y. And then 20 divided by 4 is going to give us 5. And there's our final answer. Okay, any questions? Yeah. Yeah, that's what helps you. So when you list them all off, she was just saying, hey, you always know that it's going to be the opposite number. So if I know I'm pulling the 4 out, then when I pull the 4 out from the 12x, it leaves me with the 3, right? So we know that that opposite number from the factor is what's going to be remaining. It's a good observation. All right, what you are doing for today, your assignment is going to be a GEM kit. Keep in mind that when we do GEM kits, the grade that goes into the grade book is your accuracy. So if you are just vastly clicking through to try to get as many points as you can to play the game, then you're not going to have a very good grade. So what I think we're going to do is you're going to spend the first 8 minutes just answering questions. First 8 minutes of you just answering the questions so you can build up your score as quickly as you can with those points. And then I'll let you start playing. When my timer goes off, then you can actually start playing the activity. Okay, but I want you to answer the questions, get as many points as you possibly can so that you're building up your grade. Okay?